This is HHO plug 3, and what we're going to do is we're going to work with a modified circuit here. Essentially what I've done is I've taken out the collection part that I had before, and we're just going to work with the step-up transformer, the multiplier, and our HHO spark gap. To begin this experiment, we're going to fill our vessel completely full of water and remove all the air. Then we're going to have a little bit of water bulging out before we put on our balloon on the back, or our baffle. Once we've got that set up, we're going to stand up the plug, we're going to connect it up to our circuit, and we're going to start applying pulses using the function generator to drive the transformer. And we're going to watch on the scope, and we're going to see what happens, and as well we're going to watch our plug, and we're going to compare results, and we're going to see exactly what's going on inside the spark gap. Okay, let's crank this puppy on. Here we go, we're getting our water splitting. Now if we go down, we're going to have a look. Let's watch now. As the water splits, kind of keep an eye on the bottom and on the glass. Look at the bulge happening on the bottom. There's our pressure. Oh, it fired. Where'd the pressure go? The pressure's gone. Watch again in the vessel. You can see that it's separating between the points. The gas is building on the top and it's firing again. There it goes. Now, all this time I'm adjusting the frequencies, trying to find where it's splitting the water the best and the fastest, and yet I can explode that water. Now I'm getting the frequencies quite good, and if you watch the spark, notice how white the spark is. This is what I noticed. When I run out of water, before, the spark wasn't this white. Now here I'm going to try to demonstrate to you in the prior experiments where the bubbles were forming and exploding. I'm seeing that same thing happening now. The cascade effect is actually happening in here. And I've noticed, here's another frame shot here too, try to show you the bubbles. I'll zoom in on it so you can look at the light and you can look at the bubbles a lot better. Now let's go back and have a look at it firing further back. Again, you can see our pressure on the bottom isn't that much. I'm running around 874 Hertz here. I'm finding between 500 and 800 Hertz is about the best for fracturing the water. Let's go have a quick look at the amp meter here. We can see a little bit of action on the meter, but not a whole heck of a lot. Now again, we'll go back and we'll watch and see if we can see the bubbles in there. Try to magnify it a little bit more here so that we can see it. I need to get a better camera, of course. Okay, and now what we're going to do is we're going to have a listen to this. So I'm going to turn up the volume on the camera so we can hear it. Now if you listen real close in the background, you'll hear me adjusting the frequencies. Okay, here what I'm doing is I'm actually feeling pulsing or a little bit of pressure on the bottom of the cylinder when I touch it. Alright, let's slide over to the scope. Now I've put the scope probes across the plug. Now what I'm doing is I'm adjusting the frequency to find out where it fractures the water the best, and I get the spark action. And we'll talk about the resistance. This is where the resistance in the water comes into play. Here's about the best scope shot I can get of the best fracturing of the water along with the sparking. Now the oscilloscope has a whole bunch of resistors on it, so I can measure up to 2000 volts, and I calibrated it. And as well, as I mentioned, the scope probes are across our spark gap. So now what we're going to do is we're going to try to pick out the patterns, or look at the patterns in here. And the first pattern I see is there seems to be two sections here. The off time, the long off times, and then we have like a pulse or a hill, and then it goes to off and then back up to a right there where we have a hill, and then it comes back down to what almost seems to be zero, and then on the second part of that we have this little hill or this little pulse going up. When the pulse goes up, this is when the spark gap fires. So again, it looks like we have half a sine wave going on here. So now what we're going to do is we're going to see what happens after a little while when the plug starts firing really good. Okay, I'll tune this in a little bit better. Now you see there 23 point some volts, 24 volts. Now if you take that measurement and you times it by 10, that would give us 240 volts. Now we'll double that, and that gives us roughly 480 volts. That's what my scope is calibrated to. That's what we're seeing. Now here, if we look, we can see there's a line. I like drawing lines. But what I see here is if we notice where the voltage is leveling off, it seems to climb, or it seems to ramp up. And I've noticed in the scope, maybe you can't see it too well on the camera, but I have noticed that there's a ramping effect that happens here. So as the frequency gets tuned in properly, the cascade effect starts happening, we get this ramping in voltage here with some current to it. Okay, now we're going to see what happens when the frequency isn't right. So I'm going to start adjusting that frequency, and now you can see our peaks are going up. Now if we have a look at this scope shot here, we'll see we're at 45 volts, so let's times that by 10, 450, multiply that by 2, we're looking at about 900 plus volts, where you can see we're firing between our spark gap. Now the distance of the gap in the cylinder determines at what voltage peak it'll fire at, plus resistance. So again, here with the frequency being off, it's firing a lot quicker, and it's not really fracturing the water. It's more acting like a standard spark gap where it's just firing at a particular voltage. Okay, now we're going to start putting together our circuit according to our original drawing. And what we're going to do here is I'm going to do a little experiment. I'm going to add in two lights. I'm going to add in some lights on the battery and a light on the transformer that's coming back. And I'm just going to see what happens between the two lights. They're both 12 volt 60 milliamp. They both come in the same Radio Shack package, so hopefully the ohmage is the same. Let's have a look at what happens. Now this is a little dark, hard to see, but basically the light on the left, that's the one on the battery. The light on the right, that's the one coming back from our circuit or our collection area. Now it's pretty intriguing to me that again here on the right, that bulb is a lot brighter than that light bulb that's coming off of our supply. What does that show us? Of course, we know we've got a lot of volts coming back, but we've also got current. I think I'll leave that for the next chapter in the next video.